For example 3, on rotating axes to eliminate the xy term in the equation, we're asked to take the equation 4x squared plus 4xy plus y squared minus 2 root 5x plus 4 root 5y minus 30 equals 0. Then write the equation in standard form and sketch its graph. We start with our formula to find the angle of rotation. So in this case, A is 4, B is 4, and C is 1. So when we use our cotangent 2 theta equals A minus C over B, we have cotangent 2 theta equals A is 4 minus 1 over 4, which gives us 3/4. Now, the problem we encounter that 3/4 is not on the unit circle. And at this point, we can't draw a triangle to help us because it's not cotangent of theta, it's cotangent of 2 theta. So in order to be able to draw a triangle to find out what sine and cosine are for the rest of the formula, we first have to use the cotangent double angle formula. So this is a new formula that we have not discussed this year, but it's very similar to other double and half angle formulas that we've used in terms of how it's used. So cotangent 2 theta is equal to cotangent squared theta minus 1 over 2 cotangent of theta. So from here, that means that 3/4, because that's what cotangent of 2 theta is, equals cotangent squared theta minus 1 over 2 cotangent of theta. At this point, we cross multiply. So we get 4 cotangent squared theta minus 4 equals 6 cotangent of theta. We now need to set this equation equal to 0 so we can factor. So we get 4 cotangent squared theta minus 6 cotangent theta minus 4 equals 0. Because all of our numbers, our coefficients and our constant, are even, we can divide everything by 2 to give us smaller numbers to work with. So we get 2 cotangent squared theta minus 3 cotangent theta minus 2 equals 0. We can either factor by guess and check or factor using the British method. Either way you factor, we get 2 cotangent of theta plus 1 times cotangent of theta minus 2. So if we were to multiply this together, the 2 cotangent times cotangent gives us the 2 cotangent squared. 2 times 2 would be negative 4, plus 1 gives us the negative 3 in the middle, and then 2 times positive 1 times negative 2 is negative 2. So this is our factoring, equals 0. So when we solve, we get cotangent of theta is equal to negative 1/2, and cotangent of theta is equal to 2. When we rotate, we only discuss a first quadrant rotation. So our theta, our angle of rotation, has to be between 0 and pi over 2. So we're not going to use the negative 1/2 because that would not be a first quadrant rotation. We want to use the positive 2. Now in order to use this, we now have to draw ourselves a triangle. So if we draw ourselves a right triangle, cotangent, remember, is cosine of theta over sine of theta. And this equals 2 over 1. So if our theta is here, cosine is the adjacent, sine is the opposite, and now we need to find our hypotenuse. So 1 squared plus 2 squared equals c squared, so c ends up being root 5. Which tells us that cosine of theta is 2 over root 5, and sine of theta is 1 over root 5. Once again, we're not going to rationalize these because it's going to give us common denominators to work with. So now that we have our sine and cosine, we can take these and use them in our other formulas. So now remember, our other formula is x equals x prime cosine theta minus y prime sine theta, and y equals x prime sine theta plus y prime cosine of theta. So Remember, our cosine was root 2 over 5. So x equals x prime times 2 over root 5 minus y prime times 1 over root 5. And y equals x prime times 1 over root 5 plus y prime times 2 over root 5. Simplifying these, we get x equals 2x prime minus y prime over root 5. Y equals x prime plus 2y prime over root 5. I'm just going to highlight these so I can find them later. Now that I have these equations for x and y, we're going to substitute them into our original equation and simplify. 4 times 2x prime minus y prime over root 5 squared plus 4, it was 4xy, so that'd be 2x prime minus y prime over root 5 times x prime plus 2y prime over root 5 plus y squared, which would be x prime plus 2y prime over root 5 squared minus 2 root 5 times 2x prime minus y over root 5. And I'm running out of room, so I'm going to just kind of continue down here. Minus plus 4 root 5 times x prime plus 2y prime over root 5 equals 30. So now comes the fun part of distributing everything. So as we distribute, so now when we distribute, we get 4 times 4x prime squared minus 4x prime y prime plus y prime squared. Our next term will be plus 4 times 2x prime times x prime would be 2x prime squared. 2x prime plus 2y prime would be plus 4x prime y prime. Then we have minus x prime y prime, and then we have minus 2y prime squared. And now, since we squared these, this denominator is now 5, and the same thing for the first one. This denominator is also now 5. Our next term is squaring x prime plus 2y prime, so it'll be plus x prime squared plus 4x prime y prime plus 4y prime squared over 5. Our next term would be minus, now here you'll notice that when we distribute the 5s, the root 5s cancel out, so we'll have minus 4x prime plus 2y prime. Our next term over here, same thing happens, the root 5s cancel, so we get plus 4x prime plus 8y prime equals 30. Okay, so now there's more algebra to do here. So as we continue to distribute, when we distribute the 4, we get 16x prime squared minus 16x prime y prime plus 4y prime squared. Now everything that's over 5, I'm just going to keep going and put it all over one fraction. So I'm going to try to color code to help you figure out what comes where, but then I'm going to put it all over 5 and we're going to go from there. So then 4 times 2 would be plus 8x prime squared plus 16x prime y prime minus 4x prime y prime minus 8y prime squared. Okay. This is all over 5. Okay. And I'm going to try to squeeze in this last piece here. So that's just plus x prime squared plus 4x prime y prime plus 4y prime squared. So all of this is over 5. So all of this can be easily combined. Now looking here, I have a negative 4x prime and a positive 4x prime, so they cancel, which leaves me with 10y prime equals 30. Okay, so now it's time to combine like terms here. So I have negative 16x prime y prime and a positive 16x prime y prime, they cancel. Then I have a negative 4x prime y prime and a positive 4x prime y prime. Negative 8y prime squared, which is going to cancel with positive 4 and the positive 4 here. So as I go through and finish combining like terms, I have 16x prime squared, 8x prime squared, and 1x prime squared. So that gives me 25x prime squared over 5 plus 10y prime equals 30. So, continuing to simplify, we get 5x prime squared plus 10y prime equals 30. So, we're dealing with a parabola. To put this parabola in standard form, I can divide everything by 5 and I get x prime squared plus 2y prime equals 6. Now, standard form for a parabola would be x squared equals 4py. So that's what we're trying to get to here. So I'm going to move the 2y prime to the other side. I get x prime squared equals negative 2y prime plus 6. So in order to finish getting this in the correct form, we have to factor the negative 2. So x prime squared equals negative 2 times y prime minus 3. This is a parabola with a vertex at 0, 3. And we also have a p-value, so we know that 4p is equal to negative 2. So if we divide by 4, p is negative 1/2, which tells us that this is a parabola that opens down because it's x squared, so it would be up or down, and p is negative 1/2, so it opens down. This is 0, 3 on the rotated axes. So our rotated axes, we didn't actually figure out what the angle of rotation was, but putting it in our calculator, we can find that it's approximately 26.6 degrees. So we're rotating this approximately 26, 27 degrees. And on that rotated axis, this is where things would be. But that doesn't help us very much. So what we're going to do is we're going to take this 0, 3, and we're going to substitute it back into these equations that we highlighted before. To find x would be 2 times 0 minus 3 over root 5. So x is negative 1 over root 5. And our y coordinate would be y equals 0 plus 2 times negative 3 over root 5. So y would be 6 over root 5. Negative 1 over root 5 is approximately negative 0.45, and 6 divided by root 5 is approximately 2.68. If we look at where our rotated axes would be, our rotation was approximately 26 degrees, so I've drawn in approximately where these should be. So from here, remember on the rotated axis, I would have been up 3 and over 0, so I should be somewhere right on this axis. So if I sketched it out properly, I should be at negative 0.45 and up here, which means the angle of rotation is actually a lot less than what I have it drawn out as, because this should fall right on the axes. So our angle of rotation is closer to being in here. Okay, so it's a much tighter angle of rotation. And then our p-value was down 1/2, which means that our parabola is going to open around this rotated axis, something like this. Okay, so hopefully with paper and a pencil, you can do a much better job sketching that out. But that's how all of these things work together to help us. So we find where the point would be on the regular XY plane, and then we look at our angle of rotation and know that 0, 3 should be right on that rotated y-axis. And since my point didn't line up right on that rotated axis, it told me that my rotation was off. So I fixed it and got it to line up better. So that's approximately what the graph would sketch out to be. Write the equation in standard form. We did that. Okay, this is the equation in standard form down here, where we have the x prime squared. Okay, this is our standard form. Okay, this right here. And then rotate the axes to eliminate the xy term we did, write the equation in standard form, sketch its graph. We did all that. So that's how that example is done. We can classify conics using the discriminant. Earlier we classified conics just by looking at 4AC because we didn't have a b term to look at. Now because there is a b term, we need to classify them taking that b into account, because as you saw in the last example, we had 2 squared terms, so we didn't think it would be a parabola, but in the end it was a parabola. So we have an ellipse or a circle if b squared minus 4ac is less than 0. And once again, it's a circle if a and c are equal, just like before. It's a parabola if b squared minus 4ac equals 0. And it's a hyperbola if b squared minus 4ac is greater than 0. So we're going to solve each system of equations. Before we get started, for example B, I have a typo, so we need to make sure that this minus sign in between the 3y and the x squared gets changed to a plus sign. When we're solving systems of equations, there's 2 main methods we use. The first one is elimination, the second one is substitution. If we look at this equation, I have 4x squared and 4x squared, so it seems like it would be a good one for elimination, because if we were to subtract our 2 equations, we can eliminate the x terms. In order to make sure that truly is the best way to do it, we have to look at what we'd be left with. And we'd be left with y squared, a y, and a constant, so it would be able to factor once we were done. So that's exactly what we're going to do. We're going to subtract the second equation from the first equation. So in doing so, 4x squared minus 4x squareds cancel. 9y squared, that doesn't have anything to combine with, so we get negative 9y squared. Negative 36y turns into positive 36y minus 36 equals 0. Before I finish factoring, I'm going to divide everything by negative 9. So I get y squared minus 4y plus 4 equals 0. So this will factor to y minus 2 times y minus 2 equals 0, which means y equals 2. Now to solve this, I'm going to substitute this back into one of the 2 equations. It doesn't matter which equation we substitute it into, but in this case I think the bottom one is easier because we have less to work with. There's only 2 terms in the bottom equation. So 4x squared minus 36 times 2 equals 0. That tells us 4x squared equals, I'm going to move this over at the same time that I multiply it, 72. When I divide by 4, x squared is 18, so x is plus or minus 3 root 2. Our 2 solutions are 3 root 2, comma 2, and negative 3 root 2, comma 2. For our next example, if we try to use substitution, that's going to be our better option, because trying to use elimination, we could eliminate the x squared terms, but we'd still be left with a y squared, a 2x, and a y term, which means our better option is substitution. In isolating the y, we get y is negative x squared over 3. When I substitute this into the top equation, I get negative 1/3 x squared plus negative x squared over 3 squared minus 2x equals 0. Squaring it out, I get negative 1/3 x squared plus x to the 4th over 9 minus 2x equals 0. From here, I'm going to multiply everything by 9 to eliminate the fractions. X to the 4th minus 3x squared minus 2x equals 0. I can factor out an x as a common term. I get x cubed minus 3x minus, I forgot to multiply that. That should be 18. And that's good. Okay. Minus 18 equals 0. This gets a little tricky because we know x equals 0, so there's one of our x values. But in order to figure out what our other x values are, we have to try going way back to the beginning of the year and finding the factors of 18 and doing synthetic substitution to see which factors of 18 are factors of the entire cubic. Our factors of 18 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. I'm going to start with 3. 1, I'm going to put a 0 to hold the squared term, negative 3, negative 18. Bring down the 1, 3 times 1 is 3, add I get 3, 3 times 3 is 9, add, should be a 9, add and I get 6, 3 times 6 is 18, and my first guess was a very lucky one, which means my factors are x minus 3 times x squared plus 3x plus 6. Because there are no factors of 6 that combine to 3, it means that this would give us imaginary solutions, which we don't need to worry about because we're looking for points of intersection here. Our other x value would be 3. Now we need to substitute these to find our y values. The easier equation to use would be the bottom one, 3y plus x squared equals 0, or 3y equals negative x squared. Or we could just divide by 3 now, y equals negative x squared over 3. Substituting in 0, we'd get y equals 0, so that means one of our solutions is the point 0, 0. Substituting 3, we would get y is equal to negative 9 over 3, which is negative 3. So our other solution is the point 3, negative 3. Here are your homework problems. Please do them and see me if you have any questions.